Hi everyone, today we're looking at correlation analysis. And what does correlation analysis, what does it mean? Correlation analysis helps to determine the association between two variables. That is, it helps to know the kind of relationship between two variables. It shows the direction of the variables and the strength of the variables. The correlation coefficient is usually indicated with a small r, small letter r. And as mentioned earlier, it shows the extent to which two variables are related. The R coefficient ranges from -1 to +1, that is -1 to +1. The -1 indicates that there is a negative relationship between two variables, whereas a +1 indicates there is a positive relationship between two variables. -1, when you look at the strain, indicates a perfect relationship between the two variables, although moving at different direction, that is inverse direction. The +1 indicates a perfect relationship between the two variables, although the variables are moving in the same direction. That is what the positive sign indicates. We have this data on order quantity for Y in unit, cost of good Y in $1,000 and price of good Y in 1,000. We are going to look at different scenarios. So this first one, how do we get the correlation analysis in Excel? How do we get the correlation coefficient that we can now interpret in Excel? Okay, in order to do that, we click on data, we look for the data analysis, and this is above the silver. We click on it. So you can see there's a drop box. We have different forms of analysis, but we are interested in the correlation. So we click on the correlation and we click OK. So we have the input range, the output range. So we start with the input range. You click on this and we are interested in the cost of good Y. We want to know the relationship between cost of good Y in $1,000 and the price of good Y in $1,000. We highlight the data. We click this label because when I highlighted the data, I highlighted the title for each column. So output range, click here. Where do you want your result to be? You can click anywhere. I click this place and that's it. We click OK. We have the result. You can see this is where we have the result of the correlation analysis just carried out. This shows the price, the relationship between the price of good Y and the cost of good Y. This shows a perfect relationship and it's positive. The positive sign shows that there's a direct relationship. It means that the price of good Y and the cost of good Y are moving in the same direction. That means when the cost of good Y is high, the price of good Y is also high. Or the other way around, when the cost of good Y is low, the price of good Y is low. We know the relationship between the price of good Y and the cost of good Y. It has a perfect relationship because the correlation coefficient R is 1. The two variables are moving in the same direction. When the cost of good Y is high, the price of good Y is also high. So let's look at this using the scatter diagram. We go to insert. So let's check this by using the scatter diagram. We click on the data, go to insert and click on it. Let's use this one. Can see we have the scatter diagram. So we have it. So this is good Y. You can title it good Y. We also include the labels, axis title, price of Y, cost of Y. We have that. You can see the direction of the line. You can see the direction. This shows a perfect relationship between the price of Y and the cost of Y. So when the cost of Y is high, the price of Y is also high. So this is a direct relationship between the variables cost and price of Y. Let's look at the second scenario where we have sales of good R and demand for good R. Let's go to data in order to calculate the correlation coefficient R. Go to data analysis. We click on correlation. Okay. Input range, that's our data. Always remember to check on this label because we include the label, the data title, then the output range. Where do we want the result to be? Be nice there. We click OK. Right? So we have it. Can see the correlation coefficient R for sales of good R and demand for good R is positive or quite low. That means the strength of the relationship is low because 0.3. However, the relationship is positive. That means the higher the demand for good hair, the higher the sales of good hair. That's a positive direction moving together. However, the strength is low. It's just 0.3. So let's look at this by using the scatter diagram. Click on the data. So let's check the scatter diagram for this relationship. Click on insert and click on this. Insert scatter. Click on this. You can see because the strength is low, you can see the movement. There's not like the first scenario where the direction is clearly linear. We have good hair, so we can include the axis, titles, sales of good hair. We have here the demand for good hair. Alright, we have it. The next scenario, we have demand for good B in units and demand for good hem in unit. Let's see, there's a relationship between the demand of these two different goods. So we'll go to data analysis, click on correlation and click OK. We impute the range. That is the data that we have. Here the label is checked. Then the output range, we want the result here. And we click OK. Alright, we have the result. Alright, this is the correlation coefficient R, 0.9. Quite high, very close to 1. So there's a almost perfect relationship. There's almost perfect relationship between demand for good B and demand for good hem. Maybe you need the two goods for production. So when there is high demand for B, there's most likely high demand for hem. To 0.9, very high. And it's possible the demand for the two goods are moving in the same direction. So let's check this out by using the scatter diagram because it usually makes it more visible. It makes the relationship to be more visible. Highlight the data, click on enter, click on this. Alright, you can see, although it's not perfect as in +1, but it's nearly perfect. You can see it's moving in the same direction. Demand for good M and demand for good B and M in units. So we have, let's include the axis, title, let's check it. Demand for good B, demand for good M. So we have it. Okay, so through this, if you are certain about the demand for good M, it can help you to predict how the demand for good B is going to be because they move in the same direction. They have direct relationship. So correlation analysis can help you to make prediction about the variables that you're interested in. So we move on to the next scenario. We have the demand for good S and demand for good T. Let's see the kind of relationship between these two goods. Click on data, go to data analysis, click on correlation and click OK. So we get our data here, we ensure that this is checked and output range. I want the result here. Okay, alright. So these are first case of negative correlation coefficient. Here we can see the correlation coefficient is negative 0.56 approximately. So what does this indicate? This indicates that there is a negative relationship between the demand for good S and demand for good T. That means when there is a high demand for good S, there is a tendency for lower demand for good T, and vice versa. And you can see the strength of R is 0.56. It's more like average. You can see the relationship, the strength of the relationship is like 0.56. It's not close to perfection. It's just average. So let's look at this by using the scatter diagram. Click on the data, click on insert. That's a diagram. See, based on the data we have, the movement, you can see the movement toward like opposite direction instead of what we've been used to moving in a linear direction. So this shows a negative relationship between demand for good T and demand for good S. So demand, can change the title to demand for good T and S. Axis title, demand for S, demand for T. So you can see there's a kind of inverse relationship. It's not a direct relationship, although because the strength is like 0.5, that's why you can't see it so obvious. Although it's tilted a bit compared to if it's -1 or if it has high negative value like 0.8 it's 0.9. So we look at the next scenario. We have price of feed for chicks per 50 kilogram bag in dollars and the price of a dozen chicks. So let's check the relationship between these variables. Click on data analysis, click on correlation, and okay, pick the data, label checked, the output. Okay, alright. This also shows a negative relationship between price of feed for chicks and price of dozen chicks. You can see negative 0.86, although it's quite high. So this shows that a high price of feed for chicks will result in a low price for chicks and vice versa, or a low price of feed for chicks will result in a high price of chicks. That's what that means. There's an indirect relationship between these two variables, and the strength is quite high. The strength of the relationship is high, although it is negative. So let's check what it looks like by using the scatter diagram. Insert. Okay, alright, I can see the deviation, obviously deviating in opposite direction. Shows an indirect relationship. We have price of feed and chicks. Alright, so we can include the axis title, price of feed, price of chicks. So this is related to poultry rearing. So the price of feed of chick and the price of chicks. The higher the price of feed for chicks, the lower the price of chicks. And the lower the price of feed of chicks, the higher the price of chicks. That's what the data is saying, because there's an indirect relationship between the two variables. Let's look at the next scenario. Go to data, click on data analysis, click on correlation. Okay, data, okay, label check, output range, want it here. Okay, so we have it. This shows a positive relationship, positive 0.8566, approximately positive 0.8. So there's a positive relationship between the cost of good C in carton and the price per unit, all in dollars. So there's a positive relationship. The higher the cost of good C per carton in dollars, the higher the unit price of good C. So there's a positive relationship, and it's quite high, 0.86. Let's check the scatter diagram. Click the data, go to insert, click alright, and see, you can see it shows a direct relationship. Is a direct relationship, although not perfectly linear, and it's quite high, 0.8. Let's change the title to Goody, because everything is about Goody. Alright, at the axis title, Goody price in unit. So we have Goody price in unit in dollars. Then here we have cost of Goody in cut in dollars. So we have that. So what this indicates is that the higher the cost of good C, the higher the price of good C. Alright, let's look at the next scenario. So let's go to data analysis, correlation. Okay, click on the data, label, check the output area. Okay, wow, this shows almost 0, though the strength is very low, 0.1, and it's negative. So this shows a negative relationship between the price of good A and the price of good B. There's a negative relationship, and the strength is even low. It shows that the relationship between the two variables is quite low. So let's use the scatter diagram to show this relationship. You can see there's no relationship whether direct or indirect, because the strength is low, 0.1, although the relationship is indirect, but the strength is quite low. Good A and B. Let's add the axis title, price of good B. So as we can see, you can't make prediction by using this because the relationship is low. You can't make prediction. You can't make any meaningful prediction because of the low strength relationship between these two variables. So we have this. So what can we do? How can we make this graph to look better? And it applies to other ones that we've done earlier. We can go to format, go to shape fill. Let's use nice color. You can also change the color. So you can add a line if you want to the point and give it a different color entirely. Give it yellow. You can see. So we can also look at the design and have different designs for this scatter diagram, and remove this no line. You can look at a different design. You can see, pick any one of choice, whichever one you want. Hey, what else can we do? shape effect. Look at different scenarios of the scatter diagram. So we have the typical general representation of R, coefficient of correlation. And so the case of R, it's perfectly -1. This shows a perfect inverse relationship between the two variables. And we have a case where we have the perfect +1, where we have positive direct relationship, and it's perfect in this case. It's a case of no relationship at all, where our coefficient of correlation is 0. So that means there's no relationship between the two variables. And this is a case of high correlation between the two variables, because the strength is high, 0.9, although it's negative, there's inverse relationship. And we have a case where the strength is high here, near perfect, 0.9, and it shows a direct relationship. Thank you for watching. If you're yet to subscribe to ACadeMiqPlus channel, please do. Don't forget to click on the notification button and also to like the channel.